Alright, another draft science here on YouTube video presentation. And I should have cleaned the board. I didn't do that. Yes. I'm not completely perfect. Not completely. Anyway. Okay, so yeah, I just played this part of my last video just to reiterate the point. This is the question you have to answer. This is what physics girl said happened, okay? I completely transfer the momentum, yet I lost more than half the energy. Read, that's not possible. I can't keep my momentum and then say I lost energy somewhere. If the pendulum slows down, it means the momentum is reducing. So when the pendulum doesn't quite go as far, it lost a little. And then it doesn't go quite as far and it loses a little. It means its momentum is dropping as its movement is dropping. Alright, there's a point where I say it even clearer, okay, that you can't conserve, you can't transfer 100% of something's momentum and then claim there was a bunch of energy losses. Can't happen. Can't have the right velocity. You have to lose velocity if you lose momentum. If you create noise, you have to lose velocity. You create sound, you have to lose sound, noise, same thing. You create vibrations. You create dust. You hit the atmosphere. You do anything. You move one atom. You have to subtract the movement of that one atom from your momentum. Your momentum is the only thing that can make noise. It's the only thing that can make vibrations. It's the only thing that can do all of this other stuff in the environment. So you cannot possibly ever transfer the momentum and then claim, I lost half the energy. Can't be done. All right. So on to just another example, okay? So another analogy or another thought experiment, and well, it's the rocket ship thing. We've done this before. We're going to do it again, and we're just going to say it more clearly. We're going to connect it to the bullet versus bowling ball example. So the spaceship has a bowling ball on one side, and it has a little bullet on the other side. And okay, and that's how it uses. It's SpaceX. Okay, they're doing it sort of on the cheap, and that's what it uses to steer. So it's going to use the same charge. Okay, so the same charge, and it's going to shoot bullets and bowling balls to decide how to turn the ship. All right, now the momentum argument is going to be kind of clear. Okay, it's going to say the bowling ball is going to leave really, really slowly. So it's going to have a velocity of, say, we'll use 2. Okay, bowling ball is going to leave really slow. Same charge, same explosive charge. All right, and it's weighs a lot. Okay, so it weighs whatever 6 kilograms, and it's going to leave at a very slow velocity. The bullet is going to leave at a very high velocity, 300 velocities. But it weighs a tiny amount. 1. All right. Now the fact is, it's the same charge, okay, and it's going to move mass. And the truth is the real physics would say if you do this and you do this at the same time, you've done the same exact thing. But if I use the kinetic energy formula, right, I'm gonna realize that, well, if I use the kinetic energy formula, okay, oh shit, chalk has disappeared. It's a little, oh, this video is going to have lots of technical difficulties apparently. Yeah, it's this stupid speakers doing that annoying thing again too. Alright, anyway, so momentum says 100, 100. We're just using numbers, it doesn't matter, it's exactly equal. Okay, it doesn't matter whether I shoot a bowling ball or I shoot a bullet. The fact is it's a certain amount of mass and a certain amount of velocity, and that's all it's going to matter to the equal and opposite reaction. The fact is the recoil, right? You can think of it as the recoil of the gun is going to be huge. Okay, with this dual bowling ball, it's a bowling ball for fuck's sake, right? Not really. And the bullet, it's going to be the same because it's the charge that's really deciding. But anyway. And the velocity really doesn't mean anything. So anyway, the kinetic energy formula says it isn't 100 and 100. These are not the same event. These are very, very different events. This produced only, say, 10. We'll just say this produces 10 kicks of the foot, okay, worth of energy. Okay, and it's going to say this is 300 kicks of the foot worth of energy. So the bullet, because it's going really fast, v squared, they get a huge number for how much kick it is on the spaceship. The spaceship's going to get, wow, big giant recoil, because it's a big giant pile of energy going out, right? If I have 300k going out, then it's 300k equal and opposite reaction. So my spaceship gets spun way over to this side, right? 10 to 300. That's what this formula says. Okay? This formula says the recoil on the spaceship is equal and opposite reaction. If I have 300 Ks of energy going this way, I have to have 300 Ks going this way. So I have put 300 Ks of movement this way, and this is only 6K. Well, no, 10K we said, right? 10K. That's all it is, because it's this 2 squared. 2 squared, very small. 300 squared, very big. So this disproportional, insane, like I said, if they use this formula to navigate through space, they will fail. It's overtly obvious. You will fail to successfully navigate through space because you will think, okay, that shooting bullets is really effective at moving you, and shooting bowling balls is really ineffective at moving you. And that wrong assumption, let's just say you have a bunch of different size objects, and it doesn't, because we know it doesn't matter what size they are. We know that all that matters is the pressure you create between your ship and the mass, and that's all that's going to matter, because you're going to get half the pressure and the other thing's going to get the other half of the pressure, and that's the way it's going to work. And so I'm just saying that it's quite obvious. Now, can anybody in the comments, okay, would you really say to me that if you're going to put your child inside the spaceship, okay, your child's life is going to depend on it, and it's heading right for a sun, big bright burning sun, and you're going to use this formula versus this formula, okay, as an understanding of energy turning potential? You have two choices. This one, okay, that will give you the right answers, no doubt about it. It's going to be the truth. It's going to be the actual fact about how you're going to be able to turn your ship. Or are you going to use this one? Are you going to just say to me, you believe in your Bible so much, that like Job, you will sacrifice your child to your religious notion? And this is a religious notion. It flatly will not work. It flatly will destroy you. You will die if you use this formula to decide how much your ship is going to get moved. It's a fact. It's irrefutable. It's undisputable. The formula will fail. This formula, correct answer. You will live and prosper. Do it with the other hand? I should be able to do it. This is my stroke hand. It just doesn't do it quite as well. You will live and prosper here. Okay? You will die and not prosper here. This formula will kill you. Okay? So there's another reason to hate it, because it probably will kill people. If physics keeps using it, when they go to Mars, they will die. Okay? If they use this formula, they will die going to Mars. They use this formula, they will live going to Mars. Fact. Plain, simple fact. Irrefutable fact. Undisputable fact. Yet some asshole is going to say, but there's no but. Explain how there isn't exactly as much recoil energy from shooting the bowling ball as there will be recoil energy. Well, that's probably the wrong way to say it, because you're not going to. The total movement of this, you're ejecting a certain amount of momentum. You're ejecting a certain amount of mass at a velocity. Well, yeah, there's no way other way to say it. It's just a fact. If you use this mechanism to control your spaceship, it's all about velocity. So whether I made it a bowling ball and a bullet, or I just make it atoms, it's the same principle. Okay, if I made them all the same size atoms and I shoot them faster, it means I have to use more energy to shoot them faster. It means I got rid of more energy. That means there's more recoil. Fact. And this is just telling you the same fact is true with a bowling ball. A bowling ball just means more atoms. That's all it means. It means more atoms. It means you got rid of more stuff and you got rid of it slower, and you got rid of less stuff and you got rid of it faster. That's how it works. Exactly how it works. And it has nothing to do with velocity squaring. Shouldn't mess up the good formula. Keep it sacred, Gary. Keep the sacred formula pure. Do not... Yeah, okay, sorry. But that's really what this is. Okay, and so there's people who don't really know the history of this formula at all. They keep pretending. You know, one guy leaves some jerky comment saying, oh, it's about a moment, and the other formula is about a long time. No, there's no such thing. The whole controversy for 200 years, well, the 100 years that it was actually argued, you know, where physicists took a stand and defended logic before they all pussied out. The fact is that it was a real controversy. It was a real definition of energy, not some fake thing, not some momentary thing, that wasn't the argument. The argument was a clear attack against momentum as a definition of energy. The whole existence of this formula is to replace this. That is the plan, that is the objective, that was the origin of it, that's what it was all about. The claim was this doesn't give the right answer, and this does give the right answer. That's the claim, so don't pretend it's about something else. And all I'm not telling you is that if you had to vote on one of these formulas being correct, if only one of them could be correct, and that was the absolute truth, only one of them can be correct, you really would invest in this one? You really would invest in this? Honestly. Even though there isn't a single experiment on Earth you can show me where this doesn't get the right answer. I can explain why in clay, fast things go into the clay further. I can give you a chemical explanation of why that happens. Okay, so that experiment sucks. Okay, you're not measuring the energy of something by measuring its penetrating power. You measure the energy by measuring how many molecules it moves. That's how you measure its energy. How many atoms, how many electrons, how much material does it give motion to? You add up the total motion of the material. That's how you define something's energy. And clay doesn't do it very well. All right. It gives you a distorted view. It deforms more the slower you go through it. Okay. So yeah, this is too simple. You can't argue with the facts. The bowling ball going 10 miles an hour is the same energy as the bullet going 300 meters per second or whatever. Same energy. Same effect on the ship. So go ahead, tell me I'm wrong. Go ahead and tell me I'm full of shit. Go ahead and say it, okay? Just so you can put your name down as belligerent asshole. Okay, so because that's all it's going to come down to. Because no physicist is going to tell me I'm wrong. No NASA engineer is going to say, oh yeah, we invest in this formula when we decide how to turn a ship. Because they never do that. Because they're successful. And you can't be successful using that formula. You have to use this one. Yeah, that's it. See how that goes. This has been a DraftScience video presentation. But I'm talking to the wind, right? Dumb wind. I mean, it's not, there's no sign that the wind even has the tiniest few organized neurons. I'm just talking to blowhard religious jerks. Frankly, that's all there is.